Good evening. Today I'll be presenting the case study of Kansai Airport. My group consists of myself, Shalin Sharmila, Muhammad Azman, and Ahmad Irshad. Before I begin the presentation for today, let's take a look at the location of the site. Kansai is a region located in Japan. Kansai International Airport is built on Osaka Bay, a prefecture of Kansai. The idea behind establishing the airport was due to the overcrowded of Osaka Airport. Due to lack of land, they choose to build it on an island. The only downside, they need to build the island first. One of the most ambitious projects designed by Renzo Piano. In order to begin the project, it was important for them to know the geology of Osaka Bay. As it can be seen, the geology of Osaka Basin comprises of interbedding layers of soil. The profile includes Pleistocene marine clay layers and Holocene marine clay layers alternated with sand layers, as well as very thin of volcanic ash deposit. Pleistocene marine clay and non-marine clay and sand is about 17 to 25 meters, while Holocene marine clay layer constitute the upper 400 meter of the subsea bed profile. 63 borings were made with depth of 100 to 200 meter. 6 borings were made to a seabed depth of 400 meter. This was to know the bearing capacity of soil to ensure it from collapsing or crash of airplane on a soft soil. Before filling the site, studies were done to ensure that an even compacted layer can be produced. Sand drain method was employed. The construction of the airport can be broken down into 4 stages. First is the installation of vertical sand drain, which fully penetrating the Holocene marine clay. It was placed on a 2.5 meter square pattern beneath the reclamation area. 1 million sand drains were installed. It was done to drain out the water from the soil. The first stage also includes the placement of a 1.5 sand blanket on the sea floor. Weight of piled sands forces water in the clay to move upward, as can be seen in the video right now. When this happens, it will strengthen the seabed profile. As it can be seen, seabed was improved by sand drain method and tripod block was installed for wave energy dissipation. The construction began in 1986. The second stage includes the construction of sea wall. Reclamation of airport island is the third stage, and the final stage was construction of the airport facilities. As it can be seen here, the initial height of the airport was to be 30 meters but was increased to 33 meters due to settlement forecasts. Based on the studies, it was said that 3 mountains was excavated to fill the site. For this project, 1 million workers were employed for 10 million work hours and a duration of 3 years. The soil was compacted to ensure an even surface layer for the airport. It was one of the most ambitious projects, as working with marine clay layer is a challenge by itself. The seawall was constructed to 30 meter height with 48,000 tetrahedral blocks with rocks. In 1994, the construction was completed. A 4,000 feet wide and 2.5 miles long airport was built. Then the question was raised: how do you connect an airport which is in the middle of the ocean to the land? The answer was a sky bridge. A sky bridge connecting the airport to the land. It was built using floating hydraulics. It was one of the most expensive bridges project to be built in the world. It cost $1 billion. Based on the studies made, it was believed to be one of the longest bridge in the world. It accommodates cars and trains underneath. Using steel structure was key to this project. It results in uniform stress distribution. It is known as a floating airport as it lands in the middle of the ocean. Not long after, problem arises for Kansai Airport. Cracks started appearing in the terminal building. and investigating what was the factor causing the cracks, because it was obvious the cracks was due to the stability problem of the terminal. When investigated, it was known that in 1999, 8.2 meter settlement have occurred compared to the predicted value of 5.7 meters, and this was due to the incomplete consolidation, wrong estimation of time required for completion of consolidation, ineffectiveness of sand drain, boring depth was not deep enough, and the actual values was higher than the lab values. To compensate for the sinking of the island, adjustable columns were designed to support the terminal building. These are extended by inserting thick metal plates at their base. This was done to elevate the terminal from further sinking. In 2007, the second runway was opened. The total cost for this project is believed to be $20 billion. Japan, being prone to natural disaster and being escaped by the two typhoon in the past, September 4, 2018, one of the strongest typhoon to hit Japan, directly hit the Kansai region. In results, Kansai International Airport sustained significant damage. Due to it, they plan to raise the runway by 1 meter. That's all from us today. Hopefully, this video has been helpful. Thank you for watching.